20%, it can completely mess this up. Huh?
20%?
What's 20?
25.
25?
20 or 25. 30%. Like from so from A to Z.
What percentage of the quizzes at homework is the homework?
Say again?
What percentage of the quizzes at homework is the homework?
The final is
You mix the quizzes and
25%,
homework
right?
to be 20 to 25%.
Yeah, the homework normally ends up being about 5%.
Oh, that's it?
Okay. I haven't done.
I told you, actually, we had a whole discussion about that. I said, I wish I could make it 0, but if I don't make it anything, nobody does it.
Is the final 25 or 20%?
So guys, think about it this way. The final, if it was 25%, you're going into it with 75% of your grades set. So the final actually cannot, normally what a student thinks is not quite true. It's not going to have as big an effect as you think. Now, at the same time, if you're really close to a grade, it could push you over. If you're really close to failing, it could push you under if you're not careful.
Oh, thanks, but it's not what we think.
All right.
Can it help us though, like if we do like really good on the
That's what I just said. That's the first thing I said. I started positive, and then I went realistic too.
If I get a C,
Dude.
could I ask you to just fail me so I can retake the class?
You could ask me.
I mean, would you do it?
No.
You wouldn't give me the F?
Now that's the weirdest question I think.
No, but it's because I can't.
You wouldn't give me
That
that.
would affect my
Five?
GPA like that.
Five?
You get the grade you earned.
For C.
Period. You get the
But
grade
like
you earned.
can-
Period.
You won't do it.
So if you want to manipulate things some way or somehow, then you need to figure out a way to do it yourself, because I'm not going to do it for you.
What if you enroll the
Okay.
But like I mean, if you have like a get a C,
So let me put this in the right mode.
you take things
You got to be in polar.
and
And then what was it again? It was
you can retake a C, but you
the problem I want to look at. Oh,
it's only transfer. So when you transfer to the bigger distance, it's not like it doesn't transfer. So if you get them off on those radar.
Oh, great.
so number 9, A. So when you solve 9A, you get, guys. So for 9A, on the answer key I got, guys. On the answer key I got down to r squared equals cosecant 2 theta. You guys with me on number 9A? Okay, so if you're not sure how to get there, for the moment, let's just start from there. I want to show you how the calculator can help you do this quickly. I require you to do this by hand, which means I require you to use the calculator to get the values. But this thing costs enough money, you should be able to do a lot more, a lot quicker for me, right? So if I have r squared equals cosecant 2 theta, to get both parts of it, because here I got to have r equals. I have to put in there positive square root. Are you guys kind of with me? Yes, sir. Yes, ma'am.
How did you set this up?
Oh, so mode is polar.
And you have degrees?
Let's see. No, radians is good. Actually, for this part, I'm going to put it degrees. Thank you. In general, you want it radians, but I'm going to show you something really cool here. So we'll put in degrees, and you'll see why here in a minute. So if I'm trying to create my table, that's something that we haven't really looked at too much on the calculator this semester was the tables. But I want to show you something kind of nifty right now. Just make sure everybody's with me. Cosecant 2 theta. Do you have a cosecant button on your calculator?
Yeah.
You do?
Yeah.
Who's that?
TA9.
Oh, all right. Those of you who have legal calculators, do you have a cosecant button on your calculator? No. So cosecant is 1 over sine. So I could put in there 1 divided by sine 2 theta, but of course it's r squared. So I have to put in there square root of 1 divided by sine of 2 theta. Theta. And it knows it's a theta now, not an x, because it's in polar mode. Now the problem with that is I left out my negative square root, so I have to put in there also negative square root 1 divided by sine to theta. All right. You guys kind of with me?
7 degrees.
Okay. Now, if I go up here to see above window where it says table set. Now, what's a really good scale in degrees if I wanted somebody to make a table for me?
2, 1, 2, 5 or 6.
I like it. So 5 or 6 is not a bad idea, but don't you then miss out on like 45 degrees and maybe you want some in-between things just to kind of make sure. So a really good one would be pi over 12, which actually comes out to be 15 degrees if you did that conversion. So 15 degrees kicks ass because then it'll be 15, 30, 45, 60, 75, 90. So you're hitting all the major ones and a few in the middle. You with me? So I want this. If I hit second window, I'll get the table set. I want to start at 0 degrees. And then I can go up to, go by 15 degrees. So it might, everybody know what that symbol there means? Good, change. So the change in my table, I want it to be 15 degrees. Every step I take down on my table should be 15 degrees more. Is everybody semi with me? Okay. One last thing I got to check. If you go to window, this is currently only going to go up to 12 degrees. I think that's not a problem. Let me see. I've been thinking too much about this. Let's everybody hit second graph to get in the table. Second graph, and they should pull up a table. Sweet.
Yeah.
So what's going on with that first, what's the story with that first entry? Why is it undefined? Because sine of 0 is 0, so cosecant would be undefined. I love it. So that's trying to tell you that at 0, here's the nifty thing. What does that mean graphically? At 0, it doesn't hit the x-axis. It must be some kind, it must be infinite. So it's probably some kind of asymptote there. Okay, maybe.
I can't get the table. I don't know why.
Wait, how do you get all those numbers?
All right, so under, let me do one more thing. Look under table set again. Second window. Make sure these two say auto. They do?
No. One of them's the ass.
Okay, I'll show you what asks mean in here because that's also pretty cool. But make sure they both say auto. Okay. Make sure you're in degrees. And make sure you have the equations in there.
For me in the window, it's always like, I have different numbers than what you have.
Is your equation exactly that? And use your mode degrees. So, do you guys understand why I went to degrees? Because radians would be very difficult for me to really tell where I am. It wouldn't be 15 degrees, 30 degrees. It'd be very difficult to kind of keep track of, am I at pi over 6 now, pi over 3? Because it would all be decimals. So I'd much rather see when I make a table, I can tell where I am now. Oh, I'm at pi over 3 now, I'm at pi over 2 now. Because you know Mr. Waller's going to want to see radians down on your page. Well, you can very easily convert these into radians. Not a big deal. Keep track of where you are. So do you guys kind of understand? We did that polar equation. The first thing we did was we made a table. What I'm trying to tell you now is you could just make the table and copy the damn things down on your paper. There's 2 tables here. I don't want to freak you out. This is a little harder problem maybe to start with, but there are 2 because I had R squared. I got the positive and the negative. You kind of with me? So I'm going to have at 0 degrees, let's try again. At 30 degrees, at pi over 6, it's going to have to go over to 1.07 and negative 1.07. You're going to have 2 points like that. Okay. Cool, maybe. Now, if I want to keep it degrees and I want to get this thing to graph it, I got to make sure that my theta step is small enough so it doesn't start doing, remember, it did all this freaky, jerky motion stuff. And my theta max kind of sucks right now. It only goes up to 12 degrees. That's not useful. So let's go up to 360 maybe. So if we graph this thing, nothing happens. Neat. There it goes. Oh my God. All right, let's do this. I think I made. Aw. Yeah, I think theta step is a little bit small. So let's make theta step 0.5. Let's see if that does okay. That's still a little small, Jeff. Oh my God. Is it going as slow as this for you guys?
No.
Aren't you happy I've done this to you? If it ever does that, by the way, you guys see what I'm doing? If it ever starts to graph something, it's taking forever, and it's got that little thinking thing, you know how that thinking thing on the side goes? Hit second on. If you hit second on, it actually just stops that calculation. It won't turn the calculator off, it'll just stop that calculation. My emulator doesn't quite work as well, but oh well. So maybe let's make theta step just a full degree. All right, that's better. That still sucks major. What the hell?
It's because the zoom failure.
Just want these to grow.
There we go. Good Lord, it took forever. Because the original equation was 2xy equals 1. Is that what it was? The number 98? So if you solve for y, you get 1 over 2x. Isn't that something like that? X can't be 0. There's a vertical asymptote there. There's a horizontal asymptote of 0.
Is that log?
Say again?
Same like log?
No. If I change my window a little bit, you can see it better. All right, just got to suffer through that part. Okay. So that should hopefully look familiar. So this is like if I had 1 over x plus 1, it would be just the vertical asymptote at -1. The whole thing would move over. Okay. Negative. Does everybody understand anything about the table? If you think about it, they just kick so much ass. 15 degrees is a really good standard table step. Because then you catch all of the major degrees that we should know. Okay. So where do you guys want to go next? What do you want to focus on? Matrices, okay. Could you grab the lights again? So what about matrices?
Look at my head, working out through the whole process.
So row reducing?
Yeah.
Okay. It's not going to be a very useful video. That's right there. I think my stand is getting all freaked out. All right, so let's do this. Let's see how I create a problem so that we know it's going to actually have a good solution. So say the answer is going to be 1, -4, 5. So then if I put, for example, x plus 2y minus z, what has to go there to ensure that that's the answer? 1. No. If I want my answer to be 1, -4, 5,
Yeah.
that point has to work in this equation.
Which one are we on?
I'm making a problem. Yeah, we're doing matrix solving of a system of equations. I don't have a system of equations, so I'm going to make one up. Yeah. So what I'm doing is I'm starting with the answer so that we know what we should get. And then I'm hoping you guys can do the, if I go 1 in, so you go 1,
negative.
minus 8 is -7, minus 5 is -12. So now if I had x minus 3y minus 2z,
so which one are we doing?
He's making a
We're
problem.
making it up right
It's a 3.
1 plus 12 is 13, minus 10,
3.
3. And then if I add, I don't know, negative 4x plus 5y minus z. That's gonna make a big old number. Negative 29.
29. Negative 29?
Negative 19?
Are we gonna have to make them on the test like this?
No. Is that difficult?
No.
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 So that's why I'm not
I
gonna
was
let you do
just
it. So how would this look as a meal? How would this?
1, 2, negative 1, negative 12.
That's how I make my test. Yes, I say, that's too easy. I'm not gonna finish it.
Negative 3, negative 2,
So we're not
3.
making
Negative
it
4,
up.
5, negative 1.
All right. So let's see if, as we do this, we are. That's right. We are capable of doing more than one thing at a time. That would be awesome. Oh no way. Oh, too bad. Sorry. Found some chocolate here. I'm excited. What would be my first couple steps here? What's my goal? If I wanted to take this all the way out, past just a triangular, I want to row reduced echelon form. Yeah, I want 1 0 0 0 1 0 0 0 1. So I've got a 1 here already. If I didn't and I had a 1 somewhere else, the first thing I could do is just move that row there with the 1. You guys with me? So I would want to maybe multiply this by negative 1 and add it to this. Multiply this by 4 and add it to that. So what I personally do when I do this kind of thing is I do both. I have that there. So I'm going to do negative row 1 plus row 2. I'm going to put the answer into row 2. Because that's going to put my 0 right there. Are you guys with me? Okay. So I can do that. The row 1's going to stay the same. Row 2 now is going to be 0, negative 5, negative 1, 15. And now I can do 4 times row 1.
0, 13.
4 row 1 plus row 3 to row 3. Now, if there's anybody here who missed this and maybe some other stuff, then you're like, what the freaking hell is going on? So you got to know how to do this. This is called row reducer for matrices. Yeah?
On the test, could we do 2 times 2 at the same time? You won't care.
I do not care. In fact, that would be awesome.
I mean, I kind of understand what you're doing is what we did way back when in algebra when we used to like try to eliminate a variable, right?
Yep.
So
That's
can
all.
like, this looks crazy. Can I just do it from the X, Y, and Z?
No, because part of this is showing me that you can use matrices. Yeah.
When we're solving, like, say, the homework and we have matrices, we would just use the row reduction. Because before the 10, we do like some diagonal things.
Oh no, that's for matrix multiplication. Is that what you're thinking about? Matrix multiplication is that you take the first row times the first column and put the answer in the first row, first column. That takes a little getting used to. Hopefully after doing some homework problems, it just starts to stick, the process. It's pretty simple once you get it, no matter what the size is, as long as it's legal to do it. It's the same process. So what am I going to get now here? 0, 13,
Negative 5.
negative 5, and negative 77. Now, what do you notice is kind of rough about the second column now that I got to move to?
No ones.
Yeah, there's no ones. That sucks. So one thing I could do to actually make this, I hate that. I can't live without my black marker and I don't have any. Oh. Let's see what happens to you. Between these two, I could try to either make a 1, if it's possible, or at least kill something. I'd have to multiply this by 13 and this by 5 to do that. Do you see? That sounds like the old stuff we had to do before. I'd much rather do that, though, than divide this row by 5 and make all these fractions that I have to keep track of. Yeah?
Would you multiply the third line by 2 and then use the 2 and 3 or something?
You can't use this row for anything on these because then you miss. The most horrible thing to do to yourself is to lose a 0. The second most horrible thing is to lose a 1. If you lose a 1, you can live without it because at the end you can just divide by whatever the hell it is and make it 1 again. That's not nearly as bad as losing a 0. Losing a 0 is going backwards, right? So let me see what's the best thing to do here. Personally, what I would do is, let me just throw this at you. There's a few ways to do this. If I double this and multiply this by 5, wouldn't that be 26 and 25? Wouldn't that be a 1 there then? You don't get taught that very often. And I don't know why not. I mean, it's a nice thing to do. I don't know if you guys are at all with me. You could do one of two things. You could multiply this by 13, this row, and this row by 5, add them, that'll make a 0 here. You'd still have a freaking 13 or a 5 there, not a 1. So personally, I'd rather make a 1 somewhere there, and I'm allowed to combine these whatever the hell way I want to. So depending on what they are, you got to think about how do I make them 1 apart. Well, if I double this one, I get 26, negative 10, and negative 154. If I multiply this one by 5, I'll get negative 25, negative 5, and 75. And now if I add those together, what happens? I get a 1, and I can put it right there where I want the 1 to be. You guys kind of with me here? So you do not, dear God, have to divide by 13 or something insane and get these ugly-ass fractions that, no. That's just silly. Let a computer do that shit. The computer didn't care. Yeah?
So, for example, what we did right now would be like R2.
So 5R2 plus 2R3. We're going to put the answer into R2 because I want the 1 to be there.
Oh, okay, so you decided what the answer was.
Yeah, sorry. Add it. Scene from Star Wars going on. So the first row we're not doing anything with. Yeah.
It's 5R2.
Here it's going to be 1, right? 0, 1, negative 15, and something. Negative 79? That's right. Yeah. Okay.
So what goes on the third row?
And the third row stays the same. And so the advantage, there's the word. The advantage of doing that is I now have a 1 right there where I need it to be. That 1 can then kill that 2. That 1 can kill that 13. Why can it kill that 2 safely? Because a 0 won't screw that 1. Right? Sort of. If you guys are with me. Do you have to do what I just did? Hell no. You don't have to. You can do, like I said, 8 and 5 and blah, blah, blah. That's fine too. But eventually you lose the 1. This is not a horrible thing, but still, it's getting you a little further from the goal. So what can I do now to kill that 2, for example? Yeah, multiply by negative 2. Oops.
So, it will be negative R2?
What's that, 158? Yeah, so this would be negative 2R2 plus R1 to R1. That's the first step. So what's going to be in R1 now? 1, 0, negative 29, 146. The middle row stays the same. And then the last row, now I can come in, I can take those out of the way so I don't mess up and look at the wrong thing. And what do I need to multiply by to make this work? Negative 13.
You can do doubles, right? Which is back. Like you do both rows on one matrix.
That's what I'm doing, yeah, exactly. Why not? Yeah. And if you really don't need to write these down, I personally actually don't write these down. I might make a mistake every now and again, but screw it. It saves me a lot of time overall. So, but if you need to, in this one I might need to. What is it? 65. No. 13 times 15 is something. I don't know. I don't want to think right now. 45 and 130, 175. You guys just don't want to help me today. 195. That's close. What do you want? And then 13 times 79, 1,040 minus 79 is 1,900. What was it?
27.
1027? So now I can add that, negative 13 row 2 plus row 3 to row 3. So I can kill that 13, make a 0 there. So I get 0, is that 0 and 0, 0? 0. Where am I at? 195 minus 5, 190. And then 1,027 minus 77 is
950.
950. And hopefully that goes into that, and it does. It goes in 5 freaking times. Yeah. So the last thing we do is taking it down to 1 and 5. Divide this last row by 190.
Oh.
Say again?
You can do that?
Oh, yeah. Anything you can do with an equation. If I had 4x equals 8.
If it's like, yeah, never mind.
Yeah. Okay. And now I can use that 1 to kill that 15. I can use that 1 to kill that 29.
Why would I do that by hand?
Say again?
Why would I do that by hand?
Why?
Yeah. Why we don't do it like by
So much better.
Yes.
No, yeah. If you know me, you know that that question makes me a little
Angry.
not angry, but it's because of the fact that you've got to know what goes into a problem. You don't just want to rely on the calculator to spit out the answer that doesn't give you any insight as to what goes into the problem. If you go into linear algebra, you want to understand matrices really well because you're going to start messing with them in so many different ways than you know exist. So the less you do completely in the calculator, the more you do by hand, the more of it just becomes ingrained. So you have a foundation to build other things on. So when teachers start teaching a lot of stuff on calculators, students don't have the foundation. Then when they come into my class next and I start putting stuff on top of it, the whole damn thing falls over. So by hand helps build that foundation on which we build other things.
we can double check by the.
Oh, hell yeah. Definitely. Not a damn thing wrong with that. I don't know, you guys need me to finish this out? I mean,
Yeah.
Yes, please.
Alright, so multiply by 15, of course, to kill that. And multiply by negative 29 to kill that. Negative 145. This will now be 1, 0, 0, 1, I think. Yeah. Right? So everybody cool with that? Yeah. So far, hey. 1, yeah. And then 0, 1, 0, negative 4. Thank you guys. So then I get my 1, negative 4, 5.
When you break from the R, like compared to 15 R row.
Oh yeah, yeah. So the 15 row 3 plus row 2 to row 2, and negative 29 row 3 plus row 1 to row 1.
Okay. Do we need to put this R1 or that on the test?
It would help. So guys, you should give me something like this here, because if you make a mistake and you don't have anything here, I am not going to waste time trying to figure out what the hell happened. If I can't see what you were doing, and you don't tell me what you were trying to do, you're not getting partial credit. So if you're sure you're going to do everything perfectly, no.
Okay.
You don't have to write.
In the
I'm gonna cross my fingers because that other shit confuses me. When I try to write it out, when I try to write it out, then I'm like, okay, here's
Here?
this.
No, back. Like that.
Oh,
Three,
2
3.
plus R3 goes to R3.
To R3?
Yeah. Because that's where we're trying to kill this 13 here.
But I'm more afraid that I'm gonna write something on
Just
that backwards.
from here looks like a
Second off for that, and then but I answered the question.
Yeah.
From here it looks like a squealing too, so.
Might work when we were on.
Yeah.
Because I'll write it down, but I'm doing it in my head, that way I can, on the next part, I'll just leave that one part out.
If this row is 0, 0, 0, 0, that's when I have to put things in terms of t. Because, yeah, because then that denotes the fact that there's an infinite number of answers, because t itself could be anything. Right? As long as you're not talking about some physical life problem like a car's one. Yeah. We did on A. That's what we did on the calculator just a minute ago. Yeah.
Will it ever end up where like the third row, your z is 0 equals 0, but then there's the top is still 1 0 0, then 0 1 0?
No, because if you think about it, there's no way for
That number to be obsolete.
you would never combine two things and rewrite both rows. So if something canceled, that means something must have been in both places. You're going to rewrite one, and the other one's still going to be something. So it's not possible to a column of zeros through row reduction. As I say that, I want to be careful that I can't think of a possibility to make that happen. So anything else we want to focus on?
Can you do number 4?
Sure. So I always fight the urge to say I did. Did you look at the answer key? Does it not?
Oh, no, I didn't even think of that.
Okay. 4b is a good example of that irreducible quadratic thing in the partial fractions we talked about.
Can you do it? Can you work on it?
I did.
I mean, it's
How about eliminate?
Oh yeah, I tried to squeeze that in at the bottom there. So when I say write the complex number. Oh, that reminds me, like 11b and 12 we should do because I didn't do this on the answer key. I don't know if you noticed. So let's do 11b. Is that right? Like, same idea. So 11b. So if I graph this thing, what's essentially going to be the point that I graph? So graphing on the complex plane, right?
R.
Yeah, exactly. So -6.
Isn't it supposed to be?
You should switch it.
why would you switch it? Is there a reason why you put it there, or do you just like it there?
How do you mean?
The I?
Oh.
Another time you did I on the Y.
Yeah, you
axis.
did.
Oh, why did I do that?
Does it matter?
It does. It totally does. This has got to be the complex plane, the complex axis. This is the real axis. I have no idea why I just did that. Because I did put the 6 on the real axis because it is real. The -10 on the complex. Sorry. It's been a long day. So now that tells me a few things. It tells me I've got to be careful about the angle I get. So there's always got to be consideration about make sure the angle that you get actually puts you in the quadrant you're supposed to be in. It's supposed to be in quadrant 3. When I get my angle, it's very often going to be a reference angle. It's not going to be the actual angle I should put as an answer. But the form I want to put it in, which really kind of just makes sense, r cosine is x, and x is now the real axis. R sine is y, and y is now the complex. So this form kind of comes directly from this form, really. But how do I figure out r? How do I figure out theta? R is nice. It's always, pretty much always the same thing. Yeah, it's going to be Pythagorean. It's going to be this straight distance, which is going to be Pythagorean. So square root of 100 plus 36. And whatever the hell that is. Yeah, 4 should go to that. 25, 9, 34 times. Is it 2 root 34? Yeah. Alright, so that's r. So all we need now is theta to finish putting this in the polar form. How do I get theta? What's true about tangent theta? Y over x, which in terms of this will be, remember it's a plus bi. So my b is like my y, my a is like my x, so this is related to b over a. So to get my theta, I just do the inverse tangent of b over a. B over a. I have no idea what it's going to be. Are you guys semi with me? I mean, the nice thing is this, a lot of the work in this section is exactly the repeat of the stuff in the polar section. When we first did polar coordinates, this is really just the conversion, right? X, Y point converting to a r theta point, in a way. It's just a different format. So what do I get? Inverse tangent of 5/3. I'm in radians. Yay.
59.
So 59 degrees, roughly. Or 1.03 radians. So then now I'm basically done. This z, this negative 10I minus 6, can also be represented by 2 root 34, cosine of whichever one you like better, plus I sine of that thing. Okay. Yes, ma'am.
How do we go, like, r equals the square root of b and a?
Because r squared equals x squared plus y squared in general. So to put that more specifically, r squared equals a squared plus b squared. Cool. So it really is exactly the same conversions as polar to rectangular, or rectangular to polar. Yeah.
In what situation is it when we have the minus 59 degrees from 360
Oh,
added to 180?
exactly. I just totally forgot what I said earlier. Is that in the right quadrant? I have to be in which quadrant? So this is my reference angle. So in this case, yeah, I got to add it to 180, and I just like to think of it as pi is 180. So I want to go 59 further. So what should be in here?
239.
239. Thank you. I said that at the beginning. I forgot it at the end. I gotta forgive me. And what you can always do is just double check at the end. Do 2 root 34 times cosine of 239. It should be roughly negative 6. Just to double check yourself. It's not going to be perfect because we rounded for that, but it should be negative 5.99 or whatever. Nice way to check yourself. Check yourself. All right. Some of you look less than satisfied with that. That's what you do every time. If I give you any complex number, you do exactly this to transform it into this format. You have to be careful about the quadrant you're in. Now you could have, to be honest, you could have just done this. Can you always do that? No, in this case you can, because both of them are just the negative. You can't always do that, because sometimes one will be negative and one's positive if you're in one of those quadrants where that's true, but in this case you could. Okay.
This it was from the beginning negative, right?
Yeah, I'm in that quadrant because of what that is. They're both negative.
So if you do positive, you have to go 180 to make it.
Yeah, because it's the same thing as going 59, facing 59, and then going back this far. That would get me to the same place. Well, not good. Is that cool? I may. Okay, so what next? Yeah.
Wait, really quick. Wait, so the modulus in the argument is the.
Yeah, the modulus is this dude, the argument. Argument basically always means the thing inside a function. The argument of a function, yeah. So I don't know why I just all of a sudden used the terminology there, but just in case. I think they were using, I can't remember they were using that terminology in the homework. Let's see. Did they use that terminology?
I have a question.
Yeah.
If it's like on quad 2 or 4,
Maybe.
where one's positive and the other one's negative, do we just have to add it to the negative one? The 180, or how to do?
Oh, what you do, one thing you can do to keep yourself straight, here we go, yeah, they do, page 557. Like I said, I'm here, so I know this reference angle is 59, and so that's 59 past 180 degrees, so I know there I just add the 180. If I was here, I would want to subtract from 360, because that's how far away I am from being 360.
And then here.
So I would not try to memorize a general way to do it. I would just say, where am I? Am I past 180? Am I almost 360? It just, that tells you what to do.
If it's on top, you just leave it.
You know, if it's here though, what would you do? You would do 180 minus the reference angle. Because you're not a full 180, you're this much before that, so you subtract it. So it all just depends on where it is as to what you do with it. So I wouldn't try to memorize, if I'm in quadrant 2, I would subtract it from 180. You could. I personally would not do that.
Right, I mean, no, what I'm saying is like, if you know it's like in the bottom, right, like on quadrant 3. No, I mean, if you're like in quadrant 2, and you come up with 120 for the degrees, you don't do anything to it, right? Because you know you're in the
Yeah,
right quadrant.
but you wouldn't. Because inverse tangent's alpha is between negative pi over 2 and pi over 2. So it would only give you stuff here. So if you want to be here or there, you'd have to convert it. Right? Here it would actually give you the negative, which is, technically it's fine to put negative angles in there. Kind of with me? But if I want to be there and I get a negative angle, it's just trying to tell me to go 180 minus that to get to where I want to be. Yeah. Okay. Josh.
Can you, just convert from polar to rectangular, r equals 1 plus cosine theta?
So a really good first step here would be,
Times by r.
yeah. And that takes care of 2 of these things, and actually it takes care of all of it, to tell you honestly. Because if r squared is x squared plus y squared, r is square root of x squared plus y squared. And I can just assume r is positive, because sometimes I can make it negative, but I'm just going to leave it, you know, I can make it always positive, so I don't have to worry about it. So I can immediately, r squared is x squared plus y squared, r is the square root of x squared plus y squared, and r cosine theta is x. Now I can subtract the x and square both sides to kill the square root if I wanted to. Right? So I can make this x squared plus y squared minus x squared, you subtract the x squared to kill the square root. And that's, as far as I would not multiply that thing out, for example.
Okay, that's what I was saying. So
Yeah.
I was gonna ask quickly.
That's not going to really help you out too much.
Right.
I mean, you would get a plus x squared that would cancel that, so it would simplify a little bit, but that's fine.
Sometimes I don't know how far to take it.
Oh yeah, I know what
How
you
do
mean.
you get square? Oh, okay.
But yeah, at least get rid of radicals, maybe. That's a good generalization.
What do you get plus x?
R cosine theta. Yeah. R sine theta is y.
Are you gonna go with the formulas again? Final.
Oh, yeah. Part of what we'll do on final exam review day is talk about which formulas you need to know and which ones I'll give you.
What, would you mind to do 7, which one, like A, B, or C, either one?
Oh,
I got the part like from how you got the point, but when you put the sine or the cosine, I didn't understand.
oh. If I give you something in polar, that's actually the easier conversion to do. Because this is r, this is theta. X is what, y is what?
R cosine
Cosine theta, r sine theta. So now I just got to plug and shove. X is r cosine theta. Right? And y is r sine theta. This is a good example of where I do not want to see decimals. Because you're not going to have to plot this point. You already did plot it in polar. So I don't want to see decimals here. Just a verification that you remember how to do cosine of 60 degrees. Right? So that your calc teacher doesn't come track me down and say, what the hell did you do with these trig? These kids don't even know what cosine of 60 degrees is, Jeff. I'm like, shit, man. So don't do that to me. What is cosine of 60 degrees? Oh.
1/2.
1/2. Good. So it's 3/2. That means sine must be root 3/2. Trust me. If they're a good calc teacher, that should be the first damn thing they do on the first day, like I do on my calc when I taught calc. I give a trig review that they can do in groups, but I'm trying to see who the hell knows their shit and who doesn't. I try to make it a big deal. I say, you got to know this quick, because we're going to do calculus, and one small piece of it is trig. You don't want that one small piece to suddenly be taking you forever. You better know this stuff.
So you just multiply the 3 by cosine.
Yeah, yeah. 3, that's 1/2. 3 times 1/2, 3x. Yeah. Yeah.
When you're converting to rectangular and you have theta equaling some kind of angle, either pi over 3, pi over 6, how do you move that into a rectangular equation?
Oh. Oh, yeah, because there's that one question, theta equals pi over 6 or whatever it was.
Yes.
A while back, yeah. So what was I know? I know r squared equals x squared plus y squared. What's the other half of that? What's the relationship that involves tangent?
Theta equals inverse tangent.
Or even better, tangent theta equals y over x. So if I have theta equals pi over 6. If I take the tangent of both sides, and some of you guys danced around doing this, I remember that. I was like, damn, if they would just, you start with this. If you do a tangent of this, that means you're doing a tangent of the other side too. Well, what's tangent theta?
Oh, y over x.
Y over x. That takes you directly to rectangular. And what's tangent of 5 over 6?
Square root 3 over 3?
I like it, right? It's root 3 over 1, so it's root 3. So y equals root 3 x.
Isn't it? It's a third. It's square root 3 over 3.
Yeah, I always remember
6, it's
if it's at 30, cosine's bigger, which means that the
3 square root 3.
wait, now did I get this backwards now?
No.
I did.
No, it's bigger.
If it yeah, well, so if it's 30
Yeah,
degrees,
it's
the
1 over root
cosine
3.
should be bigger,
Yes.
right? So I think I was.
I think that's 1 over.
I'll let you guys knee me down and forward with that.
Oh.
If it's so, this is the way I think about it, and I just didn't think about it as I was doing this. I was just take what you're. 30 degrees cosine should be bigger. Tangent sine over cosine. So it should be smaller over bigger. Yeah.
Okay, so then you'd be square root
Or yeah, you make a root 3 over 3. You can see why tangent's considered, or very, there's a few operations you do where tangent comes out to be the slope, because tangent theta is y over x, which is kind of a slope. Right? So here it does come out to be the slope of the equation. Cool. And also it kind of makes sense, if I'm at 30 degrees, my slope is smaller than at 60. So I should have the smaller option here instead of the bigger option. Kind of makes sense, another little check. Okay.
It's part of the, no, not the slope, right? It's kind of on the side.
Say again?
The X is not part of the radical, right?
No, this is a mx, yeah.
Tangent over 12.
This one?
Alright, so 12, the first step on 12. Well, first off, just remember what happens when I do this?
arc, then cosine.
End edge.
Cool.
Are we doing that one?
Yeah, that's number 12. Somebody asked me to do number 12.
Can we do, this is from the quiz.
Real quick, let me
Oh.
do number 12.
Sorry. I thought that
So
was.
3i minus 3 to the 5th power. I need to rewrite that into that form. So r and theta, what would r be? R. Yeah, just to convert that, the square root of 3 squared plus 3 squared, 9 plus 9, 18. So r equals 3 root 2. Cool. Think about this. Do you guys, if you remember your geometry, you have a isosceles triangle. And actually, more specifically, you have an isosceles right triangle. Right? This is 45, this is 45. If this is 3 and this is 3, this is going to be 3 root 2. Right? You just multiply it by root 2. And now look at the ratios. 3 over 3 root 2 is 1 over root 2, which is root 2 over 2, which is related to the 45-degree angle, the sine. Right? Ta-da. Okay, so all this. What about the angle?
Target node R is from 18.
Huh? 3 squared plus 3 squared, 9 plus 9 is 18. And then 9 factors as the square root of 9 is 3, and the 2 has to stay. So what about tangent theta? What's that going to be?
1.
Negative 1. Negative or positive. And where does that happen? What quadrant am I in here?
The 4th.
Yeah, I'm at negative 3, 3. So I've got to be, it's the real complex. Negative 3, 3, I'm actually in quadrant 2. Hopefully that's what I said on the answer key. That'd be nice.
Didn't say
Oh,
you did some?
that's right. I didn't do this one yet.
How do you got theta, like,
Say again?
how do you got negative 1?
Because tangent theta in general is y over x. In this case, it's b over a, because that's what y really is. Y is the imaginary piece. So tangent theta is almost always y over x. In fact, that's the basic definition. But y is the complex, x is the real. So what's the complex piece? 3, and the real piece negative 3, so tangent theta equals negative 1.
So on these.
Huh?
3i.
A and B are the coefficients of these things, right? It's A plus B, I. So I is not a piece of B. Cool. That sounded really strange. I is not a piece of B. No idea what that would mean. Where is this true? What angle is tangent negative 1?
45 degrees.
Yeah, it's some kind of 45 reference angle. So for me to be in this quadrant, it would be
Three pi
45
over
before
four.
180, so it'll be 135. Cool. So theta then is 135. Or it would be
3 pi.
3 pi over 4. It's 1/4 of a pi before a full pi.
So then it's just arcane theta. No.
So let's stick with radians right now. To write this by itself in polar form, it would be 3 radical 2 times cosine of 3 pi over 4 plus I sine of 3 pi over 4. Okay. So what would
Fifth power.
z to the 5th be? It would be this to the 5th power, right? So whatever the hell that is, times cosine of, here's the rule.
5 times.
If I times this, so
15
15
pi
pi
over
over 4 plus I sine of
15 pi.
15 pi over 4. Now to see the real power of this, let's take this one step further. 3 root 2 to the 5th power. 1 times 4 is 324. Oh, screw it. What is 3 root 2 to the 5th power? Somebody help me out. Actually, wait a minute. Before you do all that. So let's see. 3 root 2 to the 5th power.
That's
Cool.
a lot.
What's cosine of 15 pi over 4? 15 pi over 4. Stay with me now. It's 1/4 of a pi before 4 pi, which is really 1/4 of a pi before 2 pi, because I can just take a rotation out, right? So I'm here. So what's cosine of that? It's going to be positive, right? Because the x is positive. So it'll be, let me write like this: 1 over root 2 plus I times sine of that is going to also be 1 over root 2, but in this case it's going to be negative. Is that cool? Negative, because the y is negative down there. And you see how, all right, so let me see if you guys are with me. So if I distribute this, I get 3 to the 5th root 2 to the 5th over root 2 plus I, let me make this a minus. Like, 3 to the 5th root 2 to the 5th over root 2. So far, so good? A single root 2 cancels. Is that cool?
When did you
Where'd we
become
lose the I?
1 over the root over 2?
Oh, my poor I lost it there. Say again?
Oh, you just distributed it, never mind. Okay.
Exactly. Cool.
The bottom.
What's going on? Sorry?
The 1 over the root over 2.
Yeah, how
And
did
then
the
the
one over?
What is sine of 45? Root 2 over 2, which actually came from 1 over root 2.
Oh.
The reason I wanted to write it like that is because I knew it would cancel with one of these. Right? Not a big deal.
Pretty tricky.
Isn't sine of 45 root 2 over 2?
Yeah.
Yes.
Sine of 45 is root 2 over 2. And if I unrationalize that, isn't that 1 over root 2? Okay. So now I get root 2 to the 4th power is 2 squared is 4. Times 3 to the 5th is 3 something. It's 243?
Yeah.
Okay. So 243 times 4 minus 243 times 4 I.
Basic algebra.
So just imagine if you took 3I minus 3 and you multiplied it out, and you FOILed it out, and you FOILed it out, and you FOILed it out, do what this says, you would end up with, every time you have an I squared, you would make it negative whatever the number is, and so forth and so forth and so on and so on. You eventually get here. Yeah, so that's the power. And then you can imagine, the difficulty of this does not increase as that power increases. But the difficulty of this, holy shit, you make that a freaking 15. I am never going to do that. You put that on the test, Jeff? Screw this. I've done that before too. For my professor, I say, this is just freaking busy work. And they don't like that, trust me, so don't do that. Yeah. But anyway, is everybody semi with me? And then of course you have to figure out what the hell that is.
What do you mean,